Continuing with complex numbers and rational exponents, we've got our first example. We want to plot each number on the real number line or explain why the number is not on the real number line. So take a look at A. Square root of 4 happens to be 2, and 2 is C. Okay. B, negative square root of 4, so that would just be negative 2. That happens to be at B. Square root of negative 4. That doesn't appear to be on the real number line. Since there is no real number you can square and get negative 4. That immediately also relates to F, because there's no number I can square, real number that I can square and get negative 8. So now we need to take a look at square root of 8 and negative square root of 8. That can simplify to 2 square root of 2, because 8 is 4 times 2, square root of 4 is 2, gets to go on the outside, and approximately that's 2.8. So that means it would be D. It's really close to 3. And negative square root of 8 would just be the negative of that. So that would be A. Okay. Example 2, we've got some true-false statements. Square root of negative 1 is an imaginary number. True. That's by definition. There are no real numbers that satisfy the equation x equals square root of negative 1. That is also true. Because square root of negative 1 is imaginary, no one does math with it. That's false. What we do is we work with a symbol I to represent it. The equation x squared equals negative 1 has real solutions. False. It has imaginary solutions. And square root of negative 1 equals negative 1 because negative 1 times negative 1 is negative 1. That is false. Negative 1 times negative 1 is positive 1. Definition of I, the imaginary unit. When you take the square root of negative 1, you get I. So solving x squared equals negative 1 results in x equals plus or minus the square root of negative 1, which equals plus or minus I. So we get the complex numbers, which are a combination of a real number and an imaginary number, commonly written as A plus BI, where A is the real part and BI is the imaginary part. And you can add, subtract, multiply, and divide complex numbers. You can also graph them on the complex plane. For our purposes, we will learn how to add, subtract, and multiply them, and we can plot them on the complex plane. Adding, you combine like terms, the real part and the real, the imaginary and the imaginary. Same with subtract. Multiply, we use the area method. We have to remember I squared is negative 1, and then we combine like terms. For graphing, the x-axis is the real part and the y-axis is the imaginary part. So A plus BI plus C plus DI, we would add A and C, and we would add BI and DI, and would generally simplify into that form. Same with subtract. And then for multiply, we like the area method, so we'd have A plus BI times C plus DI, so we'd have AC, BCI, ADI, BDI squared. The I squared, notice I put with near the AC because that's going to turn into negative 1. And so we'll have the real part up front and the imaginary part at the back. And as you take a look at the complex plane, we've got the x-axis is your real numbers, and the vertical axis, the y-axis, is your complex numbers. So which point represents the complex number negative 3 plus 2i? Well, let's see. Real part's negative 3, imaginary part's 2, positive 2. So our coordinate would be negative 3, 2, which that happens to be A. And for the practice, I would like you to tell me what point the ordered pair, well, not the ordered pair, the complex number for B, C, and D. Example 4, simplifying. We got 2i times 8. Well, 2 times 8 is 16, and times I, so that's just 16i. 16i to the third, well, that's I to the third is I times I squared. I squared is negative 1, so that's negative 16i. 2i to the fourth, well, that's going to be 2 to the fourth and I to the fourth. 2 to the fourth is 16, and I to the fourth is I squared times to the second power. I squared is negative 1. Negative 1 squared is 1, so that's just 16. 2i times 8i, well, 2 times 8 is 16, and then we've got I squared, so that's 16 times negative 1, or negative 16. Sometimes you'll be given two numbers and asked to add them, subtract them, multiply them. So 3 plus 2i and negative 2 plus 4i I are our P and our Q. So to add, just replace P and Q with what they are. So 3 plus 2i plus negative 2 plus 4i. We're going to put the 3 and the negative 2 together. So that's 3 minus 2. 2i plus 4i. So that's 1 plus 6i. Subtract, do the same thing except subtract in between. So we've got 3 minus a negative 2, which is going to be 3 plus 2, and 2i minus 4i. So that's going to give us 5 minus 2i. Multiplying, as I said, the area method works really well here. So put 3 plus 2i across the top, negative 2 plus 4i down the front. Negative 2 times 3 is negative 6. Negative 2 times 2i is negative 4i. 4i times 3 is 12i. 4i times 2i is 8i squared. Negative 6 minus 4i plus 12i plus 8i squared. I just put them all together there. Negative 4i plus 12i we can combine. That's going to be 8i. I squared is negative 1. So we've got negative 6 plus 8i plus 8 times negative 1. So we've actually got negative 6 plus 8i minus 8. Negative 6 minus 8 is negative 14. So we have negative 14 plus 8i. And below you have 6 practice problems just like those above that we did in example 5. And then check this with me. Thank you.